Hello everyone, this video is about redox reactions where redox stands for reduction and oxidation. So what happens in these reactions is that a species becomes oxidized in order for some other species to become reduced. And because of that, the electrons are always involved. So for better understanding redox, what we have to do is we have to assign some numbers called oxidation numbers or oxidation states to each atom, and then looking at those numbers and seeing if they're going up or down. So oxidation state is a number that we assign basically to every atom, which is for the bookkeeping purpose to make sure and see which atom is becoming going up in number. Sorry, which number is going up or which number is going down, and based on that, deciding if the atom is becoming oxidized or reduced. So in many cases, it happens that the oxidation numbers are the same as the charges, but there are cases that the oxidation number is very different than the charges. So this example that I'm giving over here is an easier example. It's just involving simple atoms and ions. Because of that, it happens that the oxidation number happens to be exactly the same as the charges that they have. So for example, copper in this case, because the charge is +2, the oxidation number is also +2. Aluminum is neutral, so the oxidation number is 0. For copper, it's also 0. And for this one is +3. However, there are cases that the oxidation numbers are going to be different in more complex cases, like when they are in a compound. For that, I have another video that I've made, so I'll tag it over here. You can take a look at that video to learn more about the rules for assigning oxidation numbers. So let's take a look over here. So as we can see, the number, the oxidation state is going down for copper. It's going from +2 to 0. Whenever the number goes down, this process is considered as reduction. Whereas for aluminum, the number is going up from 0 to +3. Whenever the number goes up, this process is considered as oxidation. So I've written it over here. Oxidation is when the oxidation number goes up, whereas reduction is when the oxidation number goes down. Now, each overall reaction that it's a redox reaction is made from two half reactions. So we have a reduction half reaction and an oxidation half reaction. So for the reduction half reaction, it's the reaction of copper 2 plus becoming copper solid. So for balancing these half reactions, we always have to add electrons to the side that it's more positive. The reason is because electrons carry a negative charge with them. So in order to balance the charge on both sides, if you add it to the side that it's more positive, the charges will be balanced. So since the left-hand side has a charge of +2, I have to add 2 electrons to the left-hand side. So this would be my half reaction for the reduction. Now for oxidation half reaction, we have to write the reaction for aluminum becoming aluminum 3 plus. So again, for balancing the charge, this time I have to add 3 electrons to the right-hand side. So the left and right-hand side have the same charge. And if you take a look at the box over here, I mentioned oxidation is always the loss of electrons. So as you can see, aluminum is being oxidized and it's losing 3 electrons. So it proves that. And then reduction is the gain of electrons. So copper 2 plus is gaining 2 electrons to become reduced. So you can think about oxidation and reduction based on both definitions. You can either look at the oxidation number and see if it's going up or down, or you can look at the electrons and see whichever side the electrons is on. Based on that, decide if it's an oxidation or reduction. Now, we also have an overall reaction, which is the sum of the two half reactions. One thing to note is that overall reaction never has electrons in it. So in order to write the overall reaction, we have to make sure we cancel the electrons on for both half reactions. So because the first half reaction has 2 electrons on the left, we have to multiply that by a 3 and then multiply the second one by a 2 so that we end up getting 6 electrons on the left and 6 electrons on the right. And this way the electrons will be balanced. So my overall reaction will end up being 3 copper 2 plus 2 aluminum solid becoming 3 copper solid plus 2 aluminum 3 plus. Okay, and now the overall reaction is balanced. And as you can see, it's not as simple as just saying there's a copper on the left, a copper on the right, or an aluminum on the left, aluminum on the right. Basically, the charges have to balance too. So now we have a net of +6 on the left, a net of +6 on the right, and that's why this reaction is actually balanced. One last thing is the terms they're used as oxidizing agent and reducing agent and their meanings. An oxidizing agent is the species becoming reduced. So let me write that down. And then the reducing agent is the species becoming oxidized. So basically, the opposite thing happens to them. So the oxidizing agent becomes reduced. So think about this as like, let's say, soap, a bucket of water, mop, a sponge. All of those are considered as cleaning agents. So, but think about what happens to them after they clean stuff. So what happens is that they become dirty. They don't become more clean. And that's exactly the case over here. The species that it's an oxidizing agent is becoming reduced itself. So in this case, since copper 2 plus is becoming reduced, it's considered as the oxidizing agent, and then aluminum is becoming oxidized, so it's considered as the reducing agent. All right, so that was it for this video. I hope you enjoyed it. If you did, please make sure you like it and subscribe for watching more videos. If you have any questions, leave it in the comment section. See you in the next video.